Okay, so welcome back, and today we're going to start the next topic, and it's going to be on discrete random variables. Okay, so this is going to be part of chapter 4. I'm going to cover the general case for random, what is a discrete random variable, and as far as calculating probabilities, and also calculating things like the average. We're also going to talk about what expected mean or the expected value is. We're also going to talk about how to calculate the standard deviation and variance of a probability distribution in the general discrete case. Okay, so this starts discrete random variables. Okay, so if we take, well, I don't want to do this one. There are lots of things that cover that take a discrete random variable and make it into a probability distribution. Some of these we're going to do, some of these we're going to talk about. I'm not going to do all the examples, but I'm going to do some examples that I think are instructive and the big good ones to learn. It says small companies, like this is just an example, but it says small companies might be interested in the number of long distance phone calls their employees make during the peak time of day. Suppose that the average is 20 calls. What is the probability that the employees making more than 20 long distance phone calls during the break time? Well, those are the types of questions we're going to talk about. And in this case, that's a random variable, which is the number of calls that an employee makes. That's a discrete random variable. Okay, if we remember random variables from chapter 1, we discussed that a random variable is just a variable where the outcomes of the variable are based on some random process. And so we're going to start with the discrete case where those random variables only take on whole number values, which we also talked about discrete variables in chapter 1. Okay, so here is the notation, the variable notation. We're going to use capital letters for random variables. Okay, we're going to use lowercase letters to denote a specific value of the random variable. So for example, I might use the letter X to represent height. Okay, so this X value represents all of the values that height could be if I talk about the height of a woman. Okay, so the height of women I could denote with a capital X. But a specific height of a woman I would denote as a lowercase x. Okay, so we're going to talk about, hey, what is the probability when a random variable x is equal to a specific value of that random variable x. Okay, so that's what we're going to do. So we wanted to make sure we start using this notation for random variable. Okay, because that's going to become important as we go, as things move on. Now, in the discrete case, we're assuming that it's a count variable, right? So x is going to equal like 0, 1, 2, and so on. Okay? So, now, the probability distribution function for a discrete random variable is what we're going to start with. And this is nothing more than a table of values, okay? So what we're going to call the probability distribution function is we're going to have a table where we have the individual values. And so when we talk about a probability, a discrete a discrete probability distribution function, or what we're going to call a PDF. That's what we're talking about. We're just going to talk about a table of values, okay? We're not talking about a formula. In this case, we're just talking about a table of values, okay? Whenever we're talking about discrete random variables and you're asked, hey, what is the PDF or the probability distribution function for this experiment? All we're looking for is just a table where one column are all the values of x and the other column is the corresponding probabilities of those values, okay? So we would have, let's say 1, 0, 1, 2, and 3, and we might have the corresponding probability as 1 out of 8, and then, let's see, yeah, 4 out of 8, oops, 3 out of 8, that's what I wanted. Oops. Okay, and so let's say we have something like this. Well, this is a valid probability distribution because it satisfies the conditions that we talked about in chapter 3. Okay, so if we look at all of the values of x, so these are all the possible outcomes for x based on what I've written down. Okay, so x can be 0, 1, 2, or 3. Now, if we look at all the corresponding probabilities for each one of those outcomes, all of the probabilities are less than 1, or in between 1 and 0. Okay, so we don't have any negative probabilities, and we don't have any negative probabilities bigger than 1. Okay, so they're all between 1 and 0. Okay, and if you add up all of these probabilities, they add up to 1. So this is a valid probability distribution. Okay, so this is what we're looking at. Okay, so anytime that I ask or somebody asks you, hey, what is the PDF or what's the probability distribution function for this random variable, this is what we're looking for. Okay, in the general case for a discrete random variable. Okay, so let's do an example. So it says a child psychologist is interested in the number of newborn babies crying, or excuse me, the number of times a newborn baby's crying wakes its mother after midnight. For a random sample of 50 mothers, the following information was obtained. Let x equal the number of times per week a newborn baby's crying wakes its mother after midnight. So x is the number of times after midnight a baby's crying wakes its mother. Okay, so that's x. Okay. Now, based on the table, x, oops. So lowercase value x is going to be 0, 1, 2, 3, 4, and 5. Okay? Now, we're going to write the probabilities. So these are nothing more than relative frequencies, right? So let's say we have data and we calculate the relative frequencies. So the probabilities are just going to be the relative frequencies, okay, in this case. So here are the random sample of 50 mothers. So n is 50. So they took a sample of 50 mothers and they asked them, hey, how many times per week, or maybe they had them keep track of how many times for the next week, per week. So for the next week, they found out how many times each mother was woken up after midnight by their babies crying. Okay, and so here's what they came up with. Okay, so out of the 50, so here are the probabilities. Okay, so the first one, we got 2 out of 50, so 2 out of the 50 mothers got woken up 0 times in the past week. 11 out of 50, 1 time. 23 out of 50 mothers were woken up 2 times after midnight. 9 out of 50, 3 times. 4 out of 50, 4 times. And then 5 times, 1 mother out of 50 was woken up 5 times after midnight by their babies crying. Okay, so here is the PDF. So this is the PDF, the probability distribution for this random variable x. Okay, so that should make sense. So all we're doing is basically taking relative frequency, right? So this is a relative frequency distribution. You could look at it that way. But we're looking at this as probability from the relative frequency, like the empirical definition of probability, okay? So this would be the PDF of the example, and you're done. So if I asked you for the PDF, this is what I would look for. Now, this is what we call the discrete probability distribution function. Okay, so now let's see here. Let's see, what else do I want to do? Oh, by the way, again, look at the conditions here. So each one of these probabilities is less than, all of these probabilities are positive, right? So we don't have any negative probabilities, and we don't have any probabilities bigger than 1, right? So they're both, all the probabilities are between 1 and 0 inclusive, okay? The other thing too is if you add up all of these fractions, you get 50 over 50, which is 1. So again, this is a valid probability distribution. So just remember the conditions. So now, let's see here. Let's take another example. And in this case here, we're going to take a hospital. It says a hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. So let x equal the number of times a patient rings the nurse during a 12-hour shift. So that's x. So x is the number of times a patient So a patient will ring the nurse in a 12-hour shift. So now, this again is a random variable. It is a discrete random variable. Okay, so again, these, since we're counting the number of rings, right, the number of times a patient, so number of times a patient rings the nurse in a 12-hour period, then this is going to be something that takes the form of 1, 0, 1, 2, 3, 4, and so on. But let's say, in this case here, what do? They take 50 patients, right? So here's 50 post-op patients, because these are post-op. So this is after they had an operation, right? So probably they're in pain or something, right? Or they need something. They need help going to the washroom, whatever the case may be. So, but they're ringing the nurse for whatever reason. So now, in this case here, we know that they're taking 50 patients. Okay, same number. So n equals 50. And then x, what are the values of x? Well, based on the data, x took on the values of what? 0, 1, 2, 3, 4, and 5. So what's our PDF? Well, here's what they came up with. So here's 0, 1, 2, 3, 4, and 5. Okay, so now here's the table that they came up with. So they got 4 out of 50, 8 out of 50, 16 out of 50, 14 out of 50, 6 out of 50, and 2 out of 50. Okay, so here's the PDF. So here's the different values of how many times a patient rang the nurse and the relative frequency or the probability. Okay, so we're going to look at these as probabilities. So now, I hope you're getting the idea behind how do we construct a PDF function. So all you have to do is, when you're constructing a PDF function, is take the values, all the values of x, right? All the possible values of x, that's going to be one column of your table. And then the other column is going to be the corresponding relative frequencies or probabilities. Now, you may be given a table like we have been, where they give us the relative frequencies, or they could give us percentages, or they could give us decimals. Okay, realize that it's just based on data. Okay, but we're using this in terms to tell us something about the distribution of the population. Okay, in this case of x. Okay, so now let's see here. What can we do here? Let's see. I don't want to talk about it now. Oops. Okay, so that takes care of that. Let me look here. We did this. Let's see. Okay, I think that wraps that up. So let's talk about, once we have a probability distribution, what now? Okay, so it's one thing, just like we talked about before, to get a probability distribution. Now we're going to talk about, well, what about calculating the mean, the variance, or the standard deviation of a probability distribution? Well, it wouldn't surprise you, I hope, that it's the same thing on the calculator that we did with finding the mean or standard deviation of a frequency distribution. In fact, when I show you the formulas are very similar to the formulas that we see for weighted mean or frequency, the mean of a frequency distribution. So here is the formulas for calculating the mean, variance, and standard deviation of a discrete probability distribution. So to find the mean, mu, okay, is equal to the sum of x times the corresponding probability of x. So in other words, we're going to take these products, we're going to take these and multiply them, and then sum them up. So we're going to take 0 times this, and then 1 times this, 2 times this, 3 times this, 4 times this, and 5 times this. And then once we have all of those products, we're just going to add them up, and we're done. That's the average. Okay? So notice that this looks very similar to what we did for the x bar, right? Remember x bar of a frequency distribution or a weighted mean was this. It was the sum of x times the frequency, right, divided by the sum of the frequencies. Now, I could put over here the sum of p of x, but remember, if this is a valid probability distribution, the sum of p of x is equal to what? Always 1. So we don't need it. So all we have to do is remember this formula, okay? So now, what about the variance? Well, variance is equal to this. Oops. Let me write the general form first. So that's the general, oh, hold on, that's not right. So that's the general form for the variance, okay? But I'm going to give you the shortcut formula. So the shortcut formula is this. This is the one I would remember. I'm going to put brackets around this just so you remember what we're subtracting. Okay? So this is the one I would remember. It's easier. That's why I call it the shortcut formula. It's less tedious to calculate than the general form. They're the exact same formula. Okay? So I would remember this one because then all you have to do is use this table. Because all you're going to do is to get this piece here is square x and then do the same thing. So you just square these values and then multiply by the corresponding probabilities to get this piece, and then you just take off, you just subtract off the mean squared, okay? And of course, this is how you calculate the mean, okay? So just be aware it's the same formula. This is the one I would remember, okay? Then also, just remember that variance, or excuse me, standard deviation is just the square of the variance. Okay, so then it's just going to be the square root of this, which is just going to be that. Okay, so those are the formulas for calculating the mean, the variance, and the standard deviation for a discrete probability distribution function. Okay, so I hope that makes sense. It's pretty straightforward, and we're going to do an example. In fact, we're going to do it with this example of how you calculate all three of these. So we're going to use this example on the board, and we're going to calculate the mean, the variance, and the standard deviation for all for this one. And then we're going to probably do another example as well. So let's see here. So let's do this. Yeah, so let's do it. So now, let's calculate the the mean, the standard deviation for all of these, okay? So I'm going to erase these, and I'm going to just use the formulas to calculate each of those parameters. So now, using this PDF, let's calculate the average number of times that a patient rings the bell for the nurse. Okay, so all we're going to do is apply this formula. Okay, now, we could extend this table and just make, like we did before, just put in x times p of x. Okay, so if I do 0 times this, this is just 0. If I do 1 times this, it's just 8 over 50. If I do 2 times 16, I get 32 over 50. If I do 3 times 14, I get what? 42. Right, is that right? 3 times 30, 42, right? So I get 42 over 50. And then 4 times 6 is 24, so I get 24 over 50. And then 5 times 2 is 10, so I get 10 over 50. And then if I sum all of these down, that's going to be my answer, right? The sum of x times p of x. And so what do I get? Well, let's add, I get 8 plus 32 is 40, 40 plus 42 is 82, 102, 106, and I get 116. So I get 116 over 50. Okay, and then 116 over 50, where's my calculator? Okay, so let's see here. So I get 2.32. So this is 2.32. Or I can just use the formula, right? So let's use the formula. So all I'm going to do is apply the formula to this, right? So I'm going to do, this is equal to 0 times what? 4 over 50 plus 1 times 8 over 50 plus 2 over 16, so 2 times 16 over 50 plus 3 times 14 over 50 plus 4 times 6 over 50. Just want to make sure. Okay, so getting to the end here. So 4 times 6 over 50 plus 5 times 2 over 50. Okay, so now I should be able to see that. Yeah, I think it's on there. So if you see on there, so you should, yeah, so you see on here 0 times, so 0 times this plus 1 times this all the way down. Okay, so now 0 times anything is 0, 1 times anything is still that. So this is going to be equal 8 over 50 plus 2 times 16 is 32 over 50 plus 3 times 14 is 42 over 50 plus 4 times 6 is 24 over 50 plus 5 times 2 is 10 over 50. And you get the same thing. You get 116 over 50 or 2.32. Okay, so that's the average, right? Now, you could also do the same thing and put this in your calculator just like we did in chapter 2 with frequency distributions, okay? So the only difference is this would be list 1, right? That would be your X list. And then your probability list here would be L2. Instead of frequency list, you just put in the probability list, okay? Then you would just go to your one variable stats and put in L1 and L2 and hit enter and you're done. It will give you the same thing, okay? In fact, it'll give you all the things that I'm talking about. It'll give you the mean and the standard deviation, and then all you have to do is what? Square the standard deviation to get the variance, okay? So now here's how you get the mean. So far we have 2.32, okay? So now we have the mean, okay? So we know that mu is equal to 2.32. Now let's calculate the variance. So the variance is equal to the summation of x squared times p of x minus mu squared. Well, we know what mu is, so we got the second piece. Now all we have to do is figure out this piece. Well, all we're going to do is do the same thing, but we're going to square the x values first. Okay? So what we're going to do is we're going to get, for this piece here, right? So we're going to take this piece here, and we're going to go right here. So this piece is going to equal what? 0 squared times 4 over 50 plus 1 squared times 8 over 50 plus 2 squared over 16 over 50 plus 3 squared over 14 over 50 plus 4 squared over 6 over 50 times 6 over 50, and then 5 squared plus 5 squared times 2 over 50. Okay, now, all we do is simplify. So again, 0 squared is 0, so 0 times anything is 0. 1 squared is 1, so we still get that, so it's going to be 8 over 50 plus 2 squared is 4. 4 times 16, what's that? So 4 times 16, so that's 40. 40 plus 24 is 64. So 64 over 50. Now, what about 3 squared? 3 squared is 9. 9 times 14, well, that's, what does that give us? 90 plus 36. So that's 126 over 50. And then 4 squared is 16. And 16 times 6 is 60 plus 36, which is 96. So 96 over 50. And then 5 squared is 25 times 2 is 50. So that's just 50 over 50. So now what do we get? Well, let's just double check here. So that's 8 over 50, 40 plus 24. 40 plus 24 is 64, 9, 90, and 36 is 126. 16 times 6 is 60 plus 36, which is 96, and 50. Okay, so now we add. So these two here is going to add up to, let's say, 130. So that's 190. And then what do we get? 190, 198. That's 288, right? So let's do this again. So 126 plus 4 is 130. So plus 60 is 190. 190 plus 90 is 280. So 286. 294. So 294 plus 50. So that's going to be 344 over 50. Well, what does that give us? Well, let's find out. So this gives us what? 344. So I get 6.88. Okay, so let's double check this. I don't want to make any mistakes here. So 8. Oh, I did add wrong. Wait, no, hold on a second. So 864. No, I didn't. No, I didn't. I got it right. So 344. So we get 6.88. 6.88. Now we're not done. All we did was figured out this piece, right? So this goes with this. So now we have to add the mu squared, right? So now, what are we going to do? This is going to equal 6.88 minus the mean squared, which is 2.32. So we're going to take 2.32 and square it. And so now, what do we get? We get 6.88 minus 2.32 squared. So now, let's do that. 6.88 minus 2.32 squared. And what do we get? We get 1.4976. So we're going to get 1.498. Okay? So this is the variance. Okay? Now, how do we get the standard deviation? All we're going to do is take the square root of that. Okay, so if we take the square root, we get 1.22. So in the end, we get standard deviation of 1.22, and the variance is 1.498. Okay, and there's the mean. Now, let's do this in the calculator and see what we get. So, if we do this in the calculator, I'm just going to put the numbers in. So, I'm going to put in x here. I hope we get the right answer. So now, let's see, we got 0, let's see here, we got, so we got 8. Okay, so I got it in there, so now I'm going to go one variable stats, L1, comma, L2, hit enter. And look at that, we get the same thing. In fact, it gave me this piece also, right from the calculator. So the calculator also gives me this piece too. It gives me the mean, it gives me this piece, but it also gives me the standard deviation. And then all I have to do is square it to get this, the variance. So the calculator works too. Now, obviously, if I ask you to use the formula, make sure you know how to use these formulas, okay? So I could put that on an exam, or anyone could put that on an exam, but I prefer the calculator. As long as you understand the concepts of what the formulas are, the calculator will do the exact same thing, okay? So if I don't tell you to use the formula, then use the calculator. I would all day long, okay? So practice both ways to convince yourself and prove to yourself that you're doing it right, okay? So that's where I'm going to stop here. The next video will be on the different types of distributions that we run into that are also discrete probability distributions. This is the general case, okay? Also, actually, we also call this, and this is a good point to bring up here, is when we talk about the mean, another terminology that we use is expected value. So expected value, and we denote expected value as E of x. So where does expected value come in? Expected value comes in all over the place. In business, in the social sciences, in life insurance, any type of insurance, and also games of chance, casinos. Because we're always interested in what's the expected outcome. What should we expect if we did this over and over again? So what comes with this is the idea of that we're doing this over and over again. It's an average, right? The expected value is what do we expect to happen overall on average, okay? So this brings with it the idea of the law of large numbers that we talked about before, right? So we're expecting we're doing this over and over again, that over a long period of time of doing this experiment or doing this trial or making this sale or playing this game, what should I expect to make, or what should the expected outcome be over a long time on average, right? So it's an average over a long period of time, okay? So the expected value is the same thing. It's the mean. So whenever we hear, or you hear, or anytime we use the term the expected value, realize that all we're doing is we're talking about the mean of the probability distribution, mu. Okay? So always remember, this is what we mean by expected value. Okay? So that's one thing I wanted to make sure that I mentioned before we went on. Let's see here. Anything else that I want to mention? Yeah, I showed you how to do it on the calculator. That's it. Yeah, that's it. Let me see here. Do I want to do this one? Yeah, yeah, that's where I'm going to do it. So next time we'll talk about so here's what we're going to do. Next time, the next video that I'm going to do is going to start getting into other discrete probability distributions, but now what we're going to do is we're going to say, hey, what if we know that it has a particular distribution? This has been just general distributions, right? Just giving you a probability distribution. But what if we know that it has a particular distribution like binomial or Poisson or geometric, right? So if we know that it has a particular distribution, then we will know more information. And with more information, we can then use formulas, or let's just put it this way. Calculating probabilities, calculating the average, the variance, and the standard deviation will become easier, okay? Because we'll have formulas to be able to do that for you. Here, we have general formulas, but you have to apply the formula or the calculator. If you know something about the distribution, if you know more about the distribution, then it even becomes easier. Okay, so we'll talk about that next time. Thanks.